There's a lovely geometric interpretation of the binomial coefficients that we're going to go through next. And the interpretation is as follows. N choose k is the number of lattice paths, and we'll describe what those are. We're going to stay on the integer lattice from 0, 0 to n minus k, comma, k. So let's do an example of this. I'm going to do our favorite example of 4 choose 2, which means that what we're going to do is we're going to go from 0, 0, that's down here, and we're allowed to go over n minus k times, so there we go, and up k times. So let's populate out our lattice. Now what's a way that I could do this? Well, one way I could do this is I could go over here. Oh, sorry, I should have said I'm allowed to go over and I'm allowed to go up. No backtracking. Now I could go over or up, and then I could go up, and then I could go over, and that's an example of a lattice path. If we want to enumerate all of the lattice paths, I claim there are going to be 6 of them, so let's not take up too much space here. But what we could do is there's one step. We'll think of these as one step. Here's, and there's up. So that's one that we could do. We could do a smaller step to start, and then go up, and then go over, and then go up. That's another path. Whoa, we're losing our steps. And then we could go up. That's another path we could do. Another path that we could do that we haven't done yet is, well, let's see. We could go over here, and then we can go up 2. This is the path that I've drawn here on the board. And then we can go over 1. So I believe I've now done all the ways that we could go over first. So now that means we're going to have to go up first. So we could go up, and then we could go all the way over, and then up. Or we could go up, over just a little bit, up again, over a little bit more, and we're done. So notice each of these lattice paths that I'm drawing has 4 steps in total. And I can think about choosing which 2 of them are up steps. If I choose these 2 as up steps, my choice is now forced on me. And this is the idea. In order to get up to n minus kk, the total number of steps has got to be k to the right plus n minus k up, and I totally said that backwards, sorry, k up, and n minus k to the right, which is equal to n, and we can choose which are up. And that's the combinatorial proof. So you can see here, there's 6 different ways that we can think of these lattice paths. And the lattice path interpretation for the binomial coefficients is incredibly fruitful. It's one of the most effective ways to prove non-trivial identities about the binomial coefficients. Let's think about